and how we're breaking down that syllabus over the 6 lectures. Okay, so that document that you've picked up from the front, it's about 60 pages, so we've got to try and get through about 10 pages a lecture. Right, so you'll need to turn to page 2 of the manual. Okay, so page 1 is just the cover. So if you read through that first paragraph, right, so statistics as a discipline would be the methods of collecting, analysing and interpreting data. Okay, but with these terms, that are mentioned at the start of the notes, there are many different definitions. Okay, we could also say that statistics is the study of random variation. To understand that definition, you would need to consider the fact that an experiment is some activity that generates an outcome that we cannot predict exactly. So in other words, it's a random variable. Although we won't know the answer to the experiment, we can observe what happens. And if we have multiple observations, we have a data set. And statistics is the science of discovering patterns and structure in a data set. Now, 2 terms that will crop up again and again throughout the module would be a sample and a population. Okay, so I know you've got a definition there of population, but in general terms, does anyone have a definition of a population? What does the word population mean to you? It's all right. Okay, this word population, what does it mean? Well, what if we were interested in the average height of males in the UK? What would the population be? Yeah, British males. Okay, all males in the UK. We would need all of their heights. Okay, that would be the population. Would you agree? So, what's a population? A list of all the people that have the characteristic of interest? Okay, but does it have to be people though? Does a population need to be made up of human elements? No. So if we were interested in the average house price in Newcastle, what would be the population? All the house prices in Newcastle, would you agree? So therefore, population is a list of all the units. We would use the word units because it might be people, might not be. A population is a list of all the units that have the characteristic of interest. Okay, but as I say, there are many different definitions for these terms. Okay, so here you'll see another definition of the word population. You know, you might prefer that one. So, if that's a population, what's a sample? So, a population is a list of all the units that have the characteristic of interest, and a sample is any subset of the population. Okay? A sample is simply any subset of a population. However, a sample needs to be good. What do you think we mean by good? I'm thinking of a word that begins with R. Representative, okay? A sample is good when it is representative of the population. Okay? How do we ensure that a sample is representative of a population? We need to take the sample using some technique that ensures randomization. Okay? Each unit in the population should have the same chance of being selected. Okay, so there's some basic terms and definitions. Now, after that, and you know, I realised that this material you might be very familiar with, but remember that there are no prerequisites to this crash course in statistics. So, the next topic after those initial definitions would be data types. Okay, so we've got these two words. Okay, we've got these two words that both begin with Q. Okay, quantitative and qualitative. Okay, now are you all familiar with those words? Because, you know, don't worry if you're not, there are other words that are actually interchangeable with them. Can anyone think of a word that is interchangeable with quantitative? Begins with an N? Numerical? Okay, quantitative data is numerical data. What about qualitative? There's a word that begins with C that is interchangeable with qualitative. CAT? Begins with CAT. EG? Begins with categ. Categorical? Okay, qualitative is the same as categorical. Now, does anyone know why it's very important, it's very useful to actually classify your data as a certain type? Okay, why is it useful? If you're analysing your marine science data, why would it be useful to classify your data as quantitative or qualitative? Does anyone know? Can anyone guess? It can help us to choose the sample, that's correct. And also, think of the analysis method. Okay? There are certain analysis techniques that we use when we have quantitative data. And there are other analysis techniques that we use when we have qualitative data. Okay? So it makes sense, initially, to simply classify your data as a certain type. Okay, so we've got quantitative and qualitative, and we can break data types down a little bit further. So again, this might be useful, even though I'm sure many of you have covered this before, but with English being a second language for many of you, I think it'll still be worthwhile. So, quantitative data will either be continuous or discrete. Okay, so what's the difference between the two? Well, I would say that the temperature outside is a continuous variable. Now, would you all agree that the temperature outside is continually changing? Okay, but that isn't actually what makes it a continuous variable. Okay, the length of that pen is not changing through time, but length is a continuous variable. So what do we mean by a continuous variable? How many decimal places can you measure to in theory if the variable is continuous? Crash course in statistics? That's the material. How many decimal places can you measure to in theory if a variable is continuous? An infinite amount. That's correct. Okay, that's why it's a continuous variable. What about discrete variables? Okay, so temperatures times heights weights, they would be continuous variables. The number of people in this room, the number of chairs in this room, they're discrete variables because they're counts. Okay, still numeric, but they're counts. So you get whole numbers. Now, qualitative data. This isn't really in the syllabus for the crash course in statistics. You can see in the notes here it just mentions qualitative. But just for your own interest, it might be useful for your research in marine science. But I would say that qualitative data will either be nominal or ordinal. Okay, so this is something that you might want to add to your notes because it's not there. Just for your own interest, qualitative data will either be nominal or ordinal. Okay, so what's the difference between nominal and ordinal? Well, the first couple of letters of each word help us to remember. What did we say the alternative word was for qualitative? Began with CAT? Categorical. Now, if your categories have got no logical order, you call it nominal. Whereas if your categories do have a logical order, you call it ordinal. So, small, medium, large. What would that be? That's a logical order, so that's ordinal. Causes of medication errors in a hospital: wrong patient, wrong time, wrong treatment, wrong dose. Those categories have got no logical order, okay? So that would be nominal. What about a questionnaire that you complete? Strongly disagree, disagree, neutral, agree, strongly agree. Logical order, so therefore ordinal. Okay, so those are our data types. Now, after that, we've got a series of examples where you need to identify the data type. So, 2.1, milk yields from cows. Okay, so we've got two groups of cows. Group 1 have grazed on pasture A, and Group 2 have grazed on pasture B. So, milk yield, okay, whether it's fluid ounces or pints or gallons or litres, doesn't really matter. What's the data type? It's definitely quantitative, yeah. And is it continuous or discrete? You can measure volume. You can measure volume to how many decimal places, theoretically? An infinite amount. So therefore, this would be continuous, yeah? Would you all agree? Now, with your own research in marine engineering or marine science, are you going to be looking at milk yields from cows? I wouldn't have thought so, okay? But it doesn't matter, okay? It doesn't matter that this is a general example. as long as I show you a data set and you know what I'm talking about, there's no problem, because we're saying that this is a continuous variable. What would be some examples in marine science of continuous variables? Weights of ships, coastal wind speeds. Okay, so as long as you can think of an application for what we're doing, there's no problem. Okay, this is an example, a general example of a variable that is continuous. Okay, as long as you can think of an example in marine science of a continuous variable, there's no problem. Okay, what about eye colour of students? Blue, brown, green, grey. Okay, is that quantitative or qualitative? It's qualitative, isn't it? And if we had to be more specific, it's nominal because there's no logical order. Okay, and once you start counting the categories, okay, so 22 students have got blue eyes. Okay, once you start counting the categories, you're making it discrete. Okay, so what I'd like you to do, now, in your pairs or groups, you don't have to do this on your own, I want you to just read page 3, look at each example and work out the data type. Okay, I want you to work out whether it's quantitative or qualitative. And does everyone have a manual from the front, or does anyone need me to pass them a manual? You've all got the material? Okay, so 5 minutes to look through these examples and classify each one as a data type, quantitative or qualitative. Right, everyone, so we'll look at these examples together now. So we said before that the students' eye colours, blue, brown, green, grey, we said that that was qualitative, categorical. Again, not an example that you will see in marine science, but ship's power, steam or sail, that's categorical. Let's say we're looking at the origin of where a ship was built. UK, Europe, Africa, North America, categorical. Okay. So, students and television. The number of programs watched. Okay, so 20 students. Each student has answered the question, how many TV programs have you watched? So the data type would be, it's quantitative, it's certainly quantitative, and if we went a bit further, is it continuous or discrete? Now it's discrete, okay, because it's a count, okay? Number of programs watched, will you see this example again in marine science? No, but the number of crew on a ship, well done, number of cargoes, the number of portal visits by cargo vessels, okay, these are examples of discrete variables. Okay, insects on leaves. Insects on leaves, the data is stored in a slightly different way because it's in a frequency table, but 22 leaves have no insects on them. 23 leaves have one insect. The data type would be discrete. Okay, it's quantitative discrete again. Well done. Length of cuckoo's eggs. I didn't know this until I read this example, but cuckoos lay their eggs in the nests of other birds. So we've got two different host species, and we're looking at the lengths of the eggs. Okay, so what's the data type? The length of the eggs, like the length of a pen. It's quantitative, continuous. Well done. The tobacco virus example was another example of discrete data. And finally, the rocket engine thrusts. That was continuous. Okay, so after data types.
Can I ask you something?
Yeah, sure.
On the third example about the reduced expand, you said it was continuous because of the length.
Yeah, I realised that robin and hedgerow, these two different birds.
Can I ask you something? Because we are talking about the length, so it's more specific, the number of the length. So it doesn't matter that it's more specific. It matters the length in general.
Yeah, I mean, why they've made the decision to measure the length as opposed to the weight, I'm not sure, but certainly length is a variable, okay? It is continuous because you might be limited by the instrument that you're using, okay? Whether it's a ruler or whether it's vernier calipers, okay? But still, theoretically, there is no end point, okay?
So you take it in general because it's length.
That's right, yeah. Lengths, heights, weights, pressures, yep, these are all continuous variables. Basically, when you see numbers written down with decimal places, you can treat it as continuous, okay? Even if it isn't really continuous, it might be a rate or a percentage, you can still treat it as continuous. Okay, so after data types, we're going to look at descriptive statistics, okay? So, rather than looking at an entire data set, sometimes you would like to summarise the data set just in the form of a single number. Now, that single number might be that single number might be a measure of location. Now, what do we mean by a measure of location? It's a statistic that tells us about the size of the values, okay? So you might want to write that word down next to location, size, S-I-Z-E. Okay, so measures of location tell us about the size of the values. Next to spread, you might want to write down the word dispersion. Okay, because I would say that measures of dispersion is a more common phrase than measures of spread. Okay, so dispersion is D-I-S-P-E-R-S-I-O-N. So, measures of location tell us about the size of the values, and measures of dispersion tell us about the spread in the values. Some more notation for you. Are you all happy with the definitions of populations and samples? In our research, okay, so if you do research in marine science, marine engineering, what do you think we usually study? Do we study entire populations or samples? It's almost always samples, okay? So, the size of a sample, we use lowercase n. Can you all see that? The English or Latin lowercase n, okay, that's the size of a sample. So if you have n observations, the notation we would use for the data for the observations would be x1 through to xn. Now, what was the short word that you wrote down in your notes beginning with an S for measures of location? Size. So, averages are measures of location. So, I've got 5 numbers here, 3, 4, 5, 5 and 8. Okay, 3, 4, 5, 5 and 8. What's the average of 3, 4, 5, 5 and 8? The data set adds up to 25. So the answer is 5. Well done whoever said that. Now what is the method? What is the method that you've just used when I've asked you for the average? Did everyone divide 25 by 5? Okay, so you have used the method of... You've used the method of the mean. Okay, I only asked you for the average, okay? And there are 3 different averages. We've got the mean, the mode, the median. But people commonly think of the mean as the average. Okay, it seems very intuitive, doesn't it, just to add the values together. Okay, you add the observations together, and then you divide by the number of observations. So this is the most basic equation in statistics. The equation for a mean. We're not going to focus on much mathematical theory in this module. Okay, we're thinking more about practical applications. But if you're interested, that's the equation for the mean. So what is the symbol that we're using? X with a line written above it. How do we read that? X bar. Okay, so anytime you see a line, a straight line above a letter, you read that as bar, B-A-R. So X with a line above it would be read as X bar. So you add together the observations and then you divide by the number of observations. Now, this is a more convenient way of writing that. Now, there's a symbol that features in this equation. Again, this is just if you're interested in the theory. And I'm sure all of our Greek students will know what this this letter is. What's that letter? The Greek letter would be sigma. It doesn't matter too much if you forget that the Greek letter is sigma. Well, it matters more if you're Greek and you forget it, but if you're not Greek, it doesn't really matter. The important thing to remember is what it represents. Okay, what does it represent? Summation. Okay, so we add the observations together. Okay, we sum the observations. We then divide by the number of observations. That gives us the mean. So that's the first average. What's the second average? Before we look at the second average, just if you're interested, can you all remember the insects on leaves example? The data was stored in quite an unusual way. It was stored as a frequency table. So if your data was stored in a frequency table, the equation for the mean would be slightly different. You would need to multiply the values by the frequencies before you divide it by the sample size. But you know, in reality, okay, when you're doing research in marine science or marine engineering, you're not going to be doing these things by hand anyway, are you? You're going to be using software. Okay, so the mean's the first average. The second average is the median. Median begins with MED, obviously. Now, if you think of other words that begin with MED, like mediator, they refer to being in the middle, don't they? And the median is the middle value. Okay, it's the middle observation. But before you pick the middle observation, the middle value, if you're doing it by hand, what do you need to do with your data set? If you're doing it by hand, before you pick the middle value, you have to arrange the data in ascending order. Okay? Would you all agree that that data set there? Would you all agree that that's in ascending order? Okay, so what is the median? 5. The median has an alternative name. You might want to make a note of this one if you're not aware of it. The median has the alternative name, the 50th percentile. The 50th percentile. Okay, so the alternative name for the median is the 50th percentile. Does it make sense to everyone why it has that alternative name? It's called the 50th percentile because it's in the middle. 50% of the data is less than or equal to it. So, the median of this data set is 5. Okay, imagine that we didn't have the 8.
4.
If we didn't have the 8, the median would be 4. Well, midway between 4 and 5, 4.5. Yeah? So, if you have an odd number of observations, the median will be one specific value. But if you have an even number of observations, the median will fall midway between the middle two. Okay, so that's the median. What about the third and final average? Does anyone know what the French word mode means? The word mode in French means fashion. It is related to this, that wasn't just an aside. Mode in French means fashion. The mode is the most fashionable value, the most popular, the most commonly occurring. Okay, so what is the mode of this data set? 5. Okay, so the mean was 5, the median was 5, and the mode was also 5. Okay, so we've covered 3 averages. Which one's the best? So we've covered 3 averages. Which one's the best? Which is the best average? Well, actually, there isn't a best average. If there was an average that was the best, the other 2 wouldn't exist. Okay, so they each have their own uses. So what we'll do now is we'll look at 3 quick examples where one of the averages might be better than the others. So if you jot down these numbers, 17k, 24k, 26k, now I've got to give you the scenario before you work out the averages. The scenario is we've got a researcher on the street with a questionnaire, and the researcher has a question: how much do you earn a year? Okay, the first 3 people that answer the question, how much do you earn a year, earn £17,000 a year, so the K is 1,000, £24,000 a year, £26,000 a year, and then the 4th person in a sample of 4 is on £4 million a year, because the researcher was stood outside St James's Park and the 4th person was an overpaid footballer. Okay, so that's the data set: 17k, 24k, 26k and £4 million. So in your pairs or groups, I want you to think of the 3 averages and then decide which is the best and why. Right, everyone, so you've had a chance to think about the 3 averages and which one's the best. What's the mode? Is there a mode? No. So if all the values occur only once, there's no mode. What's the mean? Roughly. It's about 1 million, isn't it? Because the data set adds up to just a little bit over 4 million. Divide by 4, the mean is about 1 million. So there's no mode, the mean's about 1 million. What's the median? £25,000. So, what I want you to think of is why the median's the best. So I would agree with you, the median's the best. So what could be our general rule that we could use in future? With your research in marine science, what general rule can you use? I want you to complete this sentence. it is best to use the median when
when there's a great difference between the numbers. For example, here we have K and median,
so that observation would be an outlier, yeah? It's very unusual. So, general rule for your own research, it is best to use the median when the dataset contains outliers and we don't want those outliers to have an impact on the result. Okay, so that's the first example. Second example. Right, second example. Are you all familiar with the sport cricket? The sport cricket. A little bit like baseball. In cricket, like baseball, there's someone that throws the ball and there's someone that hits the ball with a bat. The more runs a batsman scores, the better he is. So, a batsman in cricket, first 5 innings of the season, has scored 2 zeros, a 2, a 98 and 400. So, what's the batsman's modal score? 0. Okay, so the mode is 0. What's the batsman's median score? 2. And what's the batsman's mean score? 100. Which is the fairest average in that situation? Well, you might disagree, but I would say probably the mean. The mode of 0 and the median of 2 seem a bit harsh, considering he did score almost a century here and then practically won a test match on his own on that occasion. So, what about a general rule for your own research? What does the mean use? What does the mean use that the other averages don't use? All of the numbers, all of the data, okay? The mean is the only average that uses all of the data, okay? So, in this example, why not take all the data into account? Okay, the same batsman scored all of these runs, so it seems fair, okay? So, the mean is the only average that uses all of the data. So, in marine research, when should you use the mean? If you want to take all of the data into account. And finally, third example, you can probably guess by deduction what the best average is going to be, but we'll try it anyway. Right, everyone, 9, 9, 9, 10, 11, 12. Before you can work out what the best average is, I need to describe the scenario. So, at a shoe shop, these were the sizes of the last 6 pairs of shoes that were sold. Okay, so there was 3 pairs of size 9 and a pair of size 10s, 11s and 12s. Right, so can anyone work out the mean? So you've worked out the mean to be 10, okay? So if you've done that in your heads, you're good at maths, and you've added up the numbers to give you 60, divided by 6, answer is 10, okay? Whether it makes sense to do that, we'll discuss shortly, but you could say at the moment the mean is 10. How many shoes are a size 10? 1. What's the median? 9.5. How many shoes were size 9.5? None. What's the mode? 9. 3 pairs of size 9. Which is the best average in that situation? Yeah, I mean, the shop owner would probably be interested in the most fashionable, the most popular shoe, the mode. But what about a general rule for your own research? When is it best to use the mode. Well, actually, it goes back to the first topic that we covered today, data types. What were our data types? What were the two words that began with Q? Quantitative and qualitative. Okay, quantitative data would either be continuous or discrete, yeah?
Yes.
Qualitative data are either nominal or ordinal. So, what is this data type? Someone's mentioned qualitative, I think. And that is actually correct. I can see why you would say discrete, because it does look discrete at first, doesn't it? Because you see numbers. Yeah? What did we say? Quantitative data, alternatively, can be called numerical data. It's either continuous when we see decimal places or discrete when we don't. Okay? So I realise that at the moment it looks discrete. However, discrete data has to be a count of something. Would you all agree? Now that doesn't mean 9 shoes, does it? That doesn't mean 10 shoes. Okay? It's shoe size 9, shoe size 10. Can you all see that these are different categories? Is there a logical order to these categories? Yeah? Shoe size 9 is the smallest, shoe size 12 is the biggest. So therefore, what is this data type? It's ordinal. That is why the mode is so useful, okay? The mode is very useful when we're dealing with categorical qualitative data, okay? You don't even have to have numbers to work out a mode, okay? Imagine that we were all stood. Imagine that we were all stood on Claremont Road and we were looking at the frequency of colours of cars, okay? If red was the most frequent, red would be the mode, okay? So there's our 3 general rules. What are they? It's best to use the median when? When there are extreme values and you don't want them to impact the answer. What about the mean? What does it use that the other averages don't use? All the data. Well done. And what about the mode? The mode is particularly useful for what data type? Qualitative. Okay, so that's the measures of location. What do they tell us about? What's the short word beginning with S? Size. What about measures of dispersion? What do they tell us about? Spread. Okay, so we will cover all of the material that's in the manuals. It's just that we might not always get through it in one lecture. So, all we'll say for now is, before we break off for our computer practical, all I want you to think of is the most basic measure of spread. It's called the range. How do you work out a range? The range of a data set would be maximum minus minimum. So what's the range of our original data set? The range of the original data set would be 8 minus 3, 5, okay? So the mean was 5, the median was 5, the mode was 5, the range is 5, and there's 5 numbers. Okay, so at the start of the computer cluster session, I'll go through a couple more measures of dispersion, and then you'll begin the practical, okay? So it's 5-2 now, so we can begin making our way up to the computer cluster on the 3rd floor.
Why did you just go along that way then?
I think we need more
Too easy.